Multiplying vectors, or you can call it product of vectors. Now, we can multiply a vector by a scalar or by a vector. Now, when we multiply a vector by a scalar, it gives a vector, just as I showed us just now. When you multiply a number or a scalar by a vector, it gives a vector. All right? So, there are two ways that we can multiply vectors. All right? Two ways. One way we produce a scalar, which we call the scalar vector, while the other we produce a new vector, which we call a vector product. I repeat that. I'm saying that there are two ways that we can multiply a vector. The first is that the first gives us a scalar, which is called a scalar vector, while the other we produce a new vector, which is called a vector product. So what I'm saying is that we have two ways of multiplying vectors. Number one is called a scalar product, and number two is called a vector product. So what we shall be doing in the next few minutes will be scalar product and vector product. Let me explain a scalar product. Now, a scalar product will give us a scalar quantity. So I'm saying that a scalar product yields scalar quantity, okay, while a vector product will give us another vector. Why? A vector product gives another vector. So these are the two ways that we can multiply vector. So now I just explained to us that a scalar product gives a scalar quantity. Now what does that mean? It means that it gives a number, okay? It gives us a number. Now we have a formula for a scalar product. For example, if I'm giving two vectors, I'm giving vector A, all right, and I'm giving vector B. Now, how do I find the scalar product of this? Now, in math, it is called the dot product. In math, it is called dot product. So we use dots to represent scalar product. Okay, so if I'm to find the dot product or the scalar product of A and B, of vector A and B, so vector A dot vector B, the formula we use to find scalar product is given as this, which is A times B cos theta. Is A times B cos theta. Now, let me explain. Please listen carefully. Very simple. Now, the theta is the angle between vector A and B. I repeat that. The theta is the angle between vector A and vector B. Now, A and B are the magnitude. So, A is the magnitude of vector A, while B is the magnitude of vector B. So let me give us in our little note form. So I'm saying that A is the magnitude of vector A, y b is the magnitude of vector b, and the angle is the, or let me say, and theta is the angle between the two vectors, So with these we can solve for the scalar product between two vectors. Now if you look at this formula, you will notice something there. In this formula for scalar vectors, you see that your right hand side is a scalar quantity. Okay, it's a scalar quantity. That means when you solve a question, you should have what? A number. I repeat that. If you look at your right hand side, you will see that it is a scalar quantity. That means when you solve a question to find the scalar product, you should get a number. That is why we call it what? Scalar quantity. So a scalar product will give us a scalar quantity or a number. Now, what about if we are asked to find the scalar product? What is A dot B? Now, scalar product is the product of two vectors. For example, when I say product, I mean that when I say what is A dot B, it means that I am multiplying two vectors with their corresponding components. In the same way I added vectors, the same way we multiply vectors. So if I'm to, let's say for example, I'm giving two vectors, but before then, I want us to note that, please note this, please. Note, very important, note please, that a scalar product is the product, or let me say, is the product or multiplication of two quantities with their corresponding components. So in the same way we added and subtracted vectors, the same way we multiply vectors. So we multiply the x component, we multiply the y component, then if there is a k component or a z component, we multiply the z component. So that is how we multiply components. We have two methods of doing this, but I'll be showing us one method. All right, it's very simple. You can check the textbook for the other method. Now, I want us to note that dot product is commutative. What does that mean? It means that vector A dot vector B will give us the same as saying vector B dot vector A. So it does not matter the way or the order of arrangement. So in this case, I'm saying that scalar product is commutative because it does not matter the way you arrange the question. You should get the same answer. All right. Now, how do I use scalar product? For example, look at this, guys. Look at this. If I'm giving a question, let's say I'm giving my vector A. My vector A is given as, it has a component of AX, AXI plus AYJ. Okay, and my vector B is giving us bxi plus byj. Now, how do I use dot product? Remember, I said that scalar product is the product or multiplication of two quantities using their corresponding components. So if I am to find the scalar product of A dot B, look at this, guys, very simple. It means that step one, I will multiply the S components, all right, the S component first. So it will be what? To be AX BX. Are we seeing that? Plus, all right, plus the Y component becomes what? AY BY. Here is how we can find the scalar product of two vectors. But if you're asked to find the angle between the two vectors, you can use this formula to find the angle. You can transpose and you can find the angle between the two vectors of that question. And you can use this formula to find the scalar product of the two vectors. So this is the concept of scalar products. Before we look at examples, I want to give us another point to note. Please, I want us to note these important points. This point I want us to note will be useful for the second method, okay? Note. This point, all right? So this point will be useful if you are using the other method for finding scalar product. Now, these are, for example, if I'm to multiply I dot I, okay, it will give me what? 1. That's the formula. If you multiply J dot J, it will give us what? 1. If you multiply K dot K, it will give us 1. So these are some very important concepts you have to remember when you are using the second method for finding scalar product. That means that if I'm to find I dot J, it will give us 0. I dot K will give us 0. Then J dot K will give us 0. So what I'm showing us here is a very important fact that you must understand when using the other method. But for this class, I'll be using this method to find my scalar products. Find the angle between the vectors. Vector A is this, and vector B is given to us. Now remember that for a scalar product, it is what? It is A, vector A dot vector B equal to A times B cos theta. I hope you guys remember this. I hope everyone remember this. Now, we have to find the angle theta. If you don't mind, we can transpose. When we transpose, we have what? Cos theta will be equal to A dot B over AB. And please remember that A this A is the what? Magnitude of A, while B is the what? Magnitude of what? Vector B. Now we can transpose this, so therefore I can say that my theta is equal to the cos inverse of vector A dot vector B over A magnitude of A times the B, the magnitude of B. So this is our formula to find the angle between the two vectors. So step one, I have to find my what? My scalar product. Remember, I said that A dot B can be solved using by multiplying the corresponding components. So step one, I multiply the x component, which is 2 and 4. So I can say is 2 times minus 4, okay, plus for the y is 3 times 2. So I have 3 times 2 plus, open brackets, 1 times minus 1. 1 times minus 1, that gives us what? Minus 1. So let me say is 1 times minus 1. Okay, so therefore we have 2 times minus 4 is negative 8. 3 times 2 is 6, so we have plus 6. 1 times minus 1 is minus 1. Minus plus is minus, so we have minus 1. So therefore, my A dot B will give us minus 8 plus 6 is minus 2. Minus 2 plus minus 2 minus 1 is minus 3. So guys, the scalar product of A and B is minus 3. So step 2, we find the A magnitude. So I can say that my A magnitude is equal to the square roots of A. We have 2 squared, 2 squared, plus 3 squared, plus 1 squared. Okay, that's for the magnitude, plus 1 squared. So that should give us 2 squared is 4, plus 3 squared is 9, plus 1 squared is 1. So that gives us 4 plus 9 is 13, plus 1 is 14. What is the square root of 14? So that gives us our A is 3.7. So A is 3.7. The same thing we do for B. So for my B magnitude is the square root of minus 4 squared plus 2 squared plus we have what? Negative 1 squared. So negative 1 squared. Negative 1 squared. Negative 1. So that gives us negative 4 squared will give us 16 plus 2 squared gives us 4 plus negative 1 squared will give us 1. So that gives us 16 plus 4, 20 plus 1 is 21. So what is the square root of 21? we have 4.6. So that is the magnitude of B. So now I have known my dot product of -3. I have known my A magnitude of A, and I have known my B. So what next? I can log in my data to find my final answer. So guys, therefore I can say that my theta, which is equal to what? Cos inverse of A dot B over A times B. Remember again that A and B are the magnitudes. So therefore, I can log in my data. I have cos inverse A dot B is -3. So I have -3 over my A is 3.7 times my B is 4.6. All right, so therefore we have cos inverse of -3. Now what is 3.7 times 4.6? I have 17.02. So next step, we divide, then we find our cos inverse. So therefore, we can say that cos inverse, open brackets, -3 divided by negative 0.1763. So therefore, we can find our final answer. So therefore, our theta is equal to cos inverse of negative 0.1763 gives us 100 degrees. So that is our final answer. So this is the angle between vector A and vector B.